Let us move on to today's class. And Khalil, I don't know, but Huzaifa आपने नहीं सबमिट किया, आप एक बार चेक कीजिए. सर इज सेइंग कि नहीं चेक किया, खलील ने किया है. Okay, so I will get Khalil's one. Khalil, can you check your answers?
Yes, sir.
हाँ बताइए तो जरा. ठीक है सारा.
So first, all are correct.
ऑल आर करेक्ट. चलो वेरी गुड, कंग्रेचुलेशन. हुजैफा आप चेक कर सकते हैं अपना. यस हुजैफा.
Yes, sir.
ये क्वेश्चन पेपर आपका ये रहेगा. दिस इज द क्वेश्चन पेपर, द असाइनमेंट. नंबर ऑफ octahedral void present in FCC.
Oh, sir, yes, I haven't submitted this one. I submitted the one before this.
Very good, very good, very good.
Yes, I'm sorry.
Okay, no problem, no problem. होता है होता है. अच्छा ये तो रहा. Okay, fine. I have got Khalil's now. 4 fine, 26 fine. Yeah. हाँ, this one is not right. ये आपने गलती कर दिया. यहाँ पे देखिए खलील.
Yes.
You see the question. What is the question?
A metal crystallizes in FCC lattice. The edge length of the unit cell is 408 picometer. The diameter of the metal atom is.
आया समझ में खलील?
Yes, sir.
समझ में आ गया ना? Okay, fine. So let us move on to today's class. Today is 7th of April. And it is what, Thursday, na? It's Thursday. Okay. So in the last class, what we saw about HCP, and then we saw that there is two different type of triangular voids, upward and downward facing. Then we put atom on this, so this got converted into tetrahedral void. This got converted into octahedral void. We also got a different type of tetrahedral void made by the layer B. And when we added atoms on the covering the octahedral void, I got ABC type. And this is also known as cubic close packing, whose unit cell is face-centered cubic. Okay. And if I put atoms here, it is not useful. But if I put atoms on the tetrahedral void made by layer B, I will get AB type. Okay. So let me see, did I cover everything from in the ABC type or not? Okay, I have got tetrahedral voids, packing efficiency relation between A and R, Z, coordination number, everything is done. Okay, fine. So let us move on to AB type. Let us move on to AB type. So please listen, don't write anything. Okay, AB type. In this, first of all, let us make some atoms here. Okay, so let me just remind you guys, how did the AB type atoms look like? So we have got atoms like this. Let me paste a few more here. A few more here. And let me get the second layer. So we have got the base of HCP in 2D. And then we are getting a few more layers. Okay. Now I need a few portions from here. And what I will do, I will put red atoms that will be covering the voids. Okay, which voids they will be covering? They will be covering these voids. So let me write this voids as these are the voids they will be covering. Okay. Okay. So let me take these atoms. And as you can see, I have covered the upward facing triangular voids and converted them into tetrahedral voids, right? We have converted them into tetrahedral voids. But as soon as we got this covered, we got a new type of void. That I am denoting with blue color. Okay, so let me increase the size if you want a better picture. So what I'm doing, so these are the new voids here, this void here, this void here. These are the new voids that I will be covering up. Okay, that I will be covering up. So if I want to cover up those voids, it's smaller. Yeah. So as soon as I will cover these voids now, you will see that I will be putting up atoms, these black atoms, on top of the black atoms of layer A. Okay, you can see here, right? So as you can see, I have got a layer A that is made of black atoms. Then we covered those voids with red atom. Then when we got a new type of void, we covered those with black atoms. And again, what did we get? Again, we got a black layer. Then if I will put again a layer, then I will get again the B layer. Okay, so this is the type of layers we have in AB type. Now what I will do, I will choose a few atoms, and as you know, to get a unit cell, I can choose any atoms. Okay, I can choose any atoms, and they will make me a unit cell. So I will take atoms in this way. I have taken the 6 atoms from the black layer. Okay, taken 6 atoms from the black layer, and what I will do, I will take 3 atoms from the red layer like this. I have taken 3 atoms from the red layer, and I will then again take the 6 atoms from the black layer. So we have A layer, then B layer, and then again the A layer. You have to complete the whole cycle: A, B, and then again A, A, B, and then again A. So we have got these atoms that we will be using in order to prepare the unit cell. So please see here, we have the black atoms like this. One more black atom here. We get a bit less space for these two. Then we have got atoms like this. One atom would be here. Then let me put one atom here. We put one atom here. Okay, and similar type of arrangement will be there in for the down out atoms also. Now what I will do, I will join them. So let me start by joining these. I will join these two. Then I will join these two. Now what I will do, I will join these lines. Yes, there is one black here also. There is one black here also. And then we have 3 red atoms. Put it here, here, and here. So all of you can see. Now this packing, it is known as HCP packing in 3D. Okay, hexagonal close packing in 3D, because it has a hexagonal type of unit cell. hexagonal close packing in 3D. Okay, hexagonal close packing in 3D. So please make this whole packing. Raise your hand when you are done. Then we will look at its coordination number, the Z of this unit cell. We will also look at the packing efficiency. Please draw this. Raise your hand when you are done. Yeah, Atif is done. Waiting for others. Waiting for Abdul Rahman, Hishma, Khalil, Saif, and Sayyid Muhammad. Waiting for Abdul Rahman, Hishma. Okay. Yeah, Abdul Rahman and Hishma only. Okay, Hishma is done. Abdul Rahman, are you here? पता ही नहीं चल रहा है. Okay. So in this, okay, fine. So Abdul Rahman is also here. Fine. All of you can lower your hand. The first thing that we will look in this is the coordination number. Okay. The first thing that we will look at is the coordination number of atom. Coordination number. I want all of you to focus on this black atom that I have highlighted in blue color. Can all of you see that? Yes or no? Please tell me. Yes or no, guys? Atif, Huzaifa. Now tell me, this black atom that I've highlighted is surrounded by, or it is touching how many black atoms? Tell me, guys. This black atom here, it is touching how many black atoms? 6 black atoms. Very good. 6 black atoms. Okay. Now, another thing that these red atoms here, now these red atoms are just on top of this black atom, and they are sitting on top of black atoms, making the tetrahedral voids, right? So this 3 red atoms are also touching the black atoms. Yes or no? Yes or no, guys? Tell me. See, you can see here, right? These 3 red atoms are just on top of the black atom, right? That is why they are touching the black atom. So now the black atom is touching 9 atoms. It is touching 9 atoms. Now you have to remember that since this is the layer A, this is layer B, this is layer A, and if I go further down, I will again get a layer B in which we will have 3 red atoms. Yes or no? We will again see 3 red atoms. The pattern will be there, no? The pattern will still exist. Yes or no, guys? Yes or no? Atif, what happened, guys? आप लोग नहीं है क्या क्लास में? हाँ? Tell me. Yes, sir. है ना? So again, what will happen? This black atom will be touching the 3 red atoms in the down layer also. So we have in the same layer 6 atoms. In the layer above we have 3 atoms. In the layer below we have 3 atoms. So in total, this black atom is touching how many atoms? The black atom is touching how many atoms, guys?
12.
12 atoms. Very good. Hai na? So the coordination number is going to be 12. The coordination number is going to be 12. Okay. So let me erase these parts. Fine. Now, next is the Z. Second thing that we have to look here is the Z. Now for Z, you can see that there are 3 different types of atoms. Okay, there are 3 different types of atoms. Here we have the B atom that is completely inside the B layer atoms, these 3 layer atoms. Then we have atoms in the corner, and then we have atom in the face center, right? This is one of the face of hexagonal unit cell you can see, and this is what? This is the face center atom. So we have here corner, and then here we have face center. And also we have atoms inside body. In body we can write, okay, not in the body center, but they are inside the body. They're completely inside the unit cell. They're completely inside the unit cell. So you have to remember, we can directly write that there are how many corner atoms? There are 12 corner atoms. But what is the contribution of each corner atom? What is the contribution of each corner atom? Now you have to be very patient here because this is not a cube. And if this is not a cube, that means the contribution will also differ for the corner atom, So as you can see, here is the corner. And then how many, once we recognize this particular corner is shared in, or it is present in how many rooms or how many unit cells, then we can decide and tell what is the contribution. So if I make unit cell, this unit cell will be made like this. Anna, you will have this type of unit cells, right? So as you can see, this one corner in the same layer, it is present in 1, 2, and 3 rooms. And this same corner will be present in the 3 rooms of the top floor also, right? The 3 rooms just above it. That is why the corner atom is present in 6 rooms, and hence the contribution is how much? The contribution is 1/6. And we have how many in total? 6 here and 6 there. That is equal to 12 corner atom. That is equal to 2. So you'll get 2 here. Okay, then we have face center atom. We have 2 face center atom, and this will be present in this room, and then the room below. This atom will be present in this room and the room above. So half will be the contribution of face center atom, and this will be equal to 1. And there are 3 in the body, and if you add them also, that will be equal to 2 plus 1 plus 3. That is equal to 6. So we have Z is equal to 6. Is there any doubt in this? Please tell me the contribution of corner or the face center. If you have any doubt, please tell me now. Okay, no one has any problem. No one has any problem. Okay. So the previous unit cells that we saw were all cubes. And they had only a dimension that is A, right? They had only A there. But in this case, we have 3 different items. What do we have? We have, you can say that this is going to be, we have 3 different dimensions, you can say, whose values are also different. So if I say that this is A, and if I say that this is B, then this length, this height here, it will be C, right? This is C. So we have three different dimensions. We have A, we have B, and we have C. Okay. And there will be different angles also, right? There will be different angles also. There will be an angle between A and B. There will be an angle between A and C, and there will be an angle between B and C. Okay. There will be an angle between B and C. Please remember, there are angles. These angles are known as alpha, beta, and gamma. Okay. Alpha, beta, and gamma. So now let me write what is the alpha angle. What is the alpha angle? So alpha angle is the angle between B and C. Okay. Beta is the angle between A and C. And gamma is the angle between A and B. Okay. Can you remember this? Yes or no? Please tell me. If I want to write the what is alpha angle, then I will say that you remove this part and this is the angle between B and C. Okay. What is the beta angle? You remove the B and the angle between A and C is the beta angle, and gamma is the angle between A and B. Is this clear? Yes or no? Please tell me.
Yes, sir.
Now you guys tell me, what do you think? What is the angle alpha? Alpha angle is what? B and C. So here we have a wall. Here we have a wall, and then we have the ceiling, right? So wall and ceiling, they are in 90 degree. Then again we have beta angle. Beta is also what? A and C. So C is again the wall, and A is again the ceiling, right? The edge that is present in the ceiling, then again 90 degree. Then when I look at gamma, gamma will be equal to 120 degree because it is a hexagon, right? It is a hexagon. This angle will be equal to 120 degree, right? This is gamma angle. Fine. So please now write these parts, coordination number Z and the alpha, beta, and gamma. Alpha, beta, and gamma. Please write this down. Let me know if you're done. Write this down. Let me know if you're done by raising your hand. Okay. You're waiting for Huzaifa, Khalil, and Muhammad Saifullah. Just waiting for Muhammad Saifullah now. This is in body, sorry, not in body, this is in body. Okay, Abdul Rahman, this is in body, these red atoms. Okay, so I think most of you are done now. Yeah, everyone is done. Right. Now, in order to calculate the packing efficiency, we need the relationship between A and R, or rather we also need the volume of the unit cell, but we have never learned about the volume of a hexagonal type of unit cell. That is why you don't need to derive the packing efficiency. You can just write the packing efficiency. It is equal to 74%. Okay, packing efficiency is equal to 74%. Last point that we even want to write in this case is the voids. And this is important. Okay, the voids are important. So we will write octahedral voids, which is equal to n, as we have seen in the last class. And n is the number of atoms, So this will be 6. And also tetrahedral void, it is equal to 2n, and where n is the number of atoms in the unit cell. Please remember, in the unit cell, this will be equal to 12. But let's suppose if I have 100 atoms, and these 100 atoms are making Hcp 3D, then we will have 100 octahedral voids, and we will have 200 tetrahedral voids. Since we are talking only voids in unit cell, then that is why we are writing n, which is equal to 6, and 2n, that is equal to 12. Okay, so please remember, this is n is what? Number of atoms. N is number of atoms. So write these 2 points. Packing efficiency is equal to 74%. Void is in the unit cell, it is equal to, void is in the unit cell, it is equal to 6 and 12. 6 and 12. Okay, and this question, it has been directly asked in the NEET examination. How many voids, how many tetrahedral voids and how many octahedral voids are there in hexagonal cubic unit cell, in one unit cell? Okay, in hexagonal unit cell. Write this down. Write this down, then you will summarize whatever we have learned till today. Done, all of you? Packing efficiency and voids, just 2 things. Is there anyone who is still writing? Is there anyone who is still writing? No? Okay, fine. So let us summarize whatever we have learned today. Let us summarize whatever we have learned today. Not today, but till today. So in the starting, we learned about the 1D packing. In the starting, we learned about 1D packing. And I hope all of you know that there is only one question that can come from one-dimensional packing. What is that question that can come from 1D packing? Does anyone remember? Guys, tell me. What is the question that can come from 1D packing? Coordination number of atom, which is equal to 2. Okay. Please start studying. Please start studying. You guys are not studying, it seems. You guys are not revising. You guys are not submitting assignments. Then we went to 2D packing. So in 2D packing, please turn the mic on. Please turn the mic on. I can't see you guys just silently sitting here. Answer me now. You have learned all of this now. Tell me, in 2D packing, how many cases are there? In 2D packing, how many cases? Yes, we have 2 cases. What are these 2 cases?
AA packing and ABAB packing.
Yeah, AAA packing and ABAB type of packing. Okay, and we also call that as square close packing in 2D and hexagonal close packing in 2D, right? So this is our AAA type and this is our ABAB type. Okay, now what is the packing efficiency of square close packing or ABAB packing? What is the packing efficiency? Tell me, what is the packing efficiency?
So 78.5.
Very good. This is 78.5. And for ABAB type packing, what is the packing efficiency?
90.6.
90.6. Very good. Anna? Now, moving from SCP, when we went to 3D, we again got 2 different cases, right? 2 different cases. I will write the unit cell for these 2 cases. Does anyone remember what are these 2 cases? There is simple cubic. Simple cubic. And then we got body centered cubic, right? BCC structure. And when we went from HCP, let me get a few bit more spaces here. And we all know in HCP we have 2 different types of voids. And when we put atoms here, we got tetrahedral voids, right? We put atoms here, this got converted into tetrahedral voids, and we got a packing that is hexagonal close packing that we have seen just now, right? HCP. And in this downward, this is tetrahedral void. And if I cover the octahedral void, I will get the ABC type packing or CCP, cubic close packing, and whose unit cell is what? FCC, face centered cubic, right? The unit cell is face centered cubic. Now we want to write a few things about all of these unit cells. The Z, the coordination number, the relationship between A and R, the packing efficiency, and the voids. Okay, and the voids. So let me draw a few lines here. You guys will tell me, okay? So for simple cubic, what is the Z? What is the Z for simple cubic? Guys, tell me.
1.
1. Very good. The coordination number. What is the coordination number? Yes, Minashi?
6.
6. Relationship between A and R?
A equal to 2R.
A equal to 2R. Packing efficiency? What is the packing efficiency? Correct, 52.4%. And what is the void? Cubical void. Correct? Very good, Minashi. Now, who will tell me for BCC? किसी ने लगता रिवाइज ही नहीं किया. बताइए. For BCC, what is the Z?
2.
2. Very good. Coordination number?
8.
Very good. Relationship between A and R.
A is equal to 4 root 3 R.
ऐसे याद कर लीजिए ना. What is the body diagonal, Khalil? Body diagonal is A root 3 है ना?
Yeah.
And this will be equal to 4R. ठीक है? Fine. A root 3 is equal to 4R. What is the packing efficiency?
68%.
68%. The void is going to be distorted octahedral, but you don't need to remember this because this will not be asked. In HCP, what is the Z? We learned it just now. What is the Z here? What is the Z, guys? अरे क्या हो गया? अभी तो किया ना, लिखा होगा आप लोगों ने. कितना है?
6.
6, right. Coordination number is
12.
12.
12.
Relationship between A and R. A तो नहीं है इसमें, A, B, C सारे हैं, तो वो पढ़ना नहीं है ना. We don't have to remember relationship between A and R for HCP. What is the packing efficiency? 74%. And then we have 6 octahedral voids and 12 tetrahedral voids. Okay. Then for FCC, the Z is equal to 4. Coordination number is again 12. Relationship between A and R, since this is face centered, it will be A root 2 is equal to 4R. And the packing efficiency is again 74%. The voids here, it will be n number of octahedral voids. That means 4 octahedral voids and 8 tetrahedral voids. Okay. So please write this down, complete this table. And these are the things that you have to remember. Okay. So even if you don't remember the conclusions and even if you don't remember the explanation and different things, but please remember this whole chart. Okay. You have 8 tetrahedral voids. Chaliye. Make this chart. Let me know when you are done. Waiting for Atif, Abdul Rahman, and Mohammed Saif. Just waiting for Abdul Rahman. Abdul Rahman, please write fast. Okay, so everyone is done. Then now we will move to questions part. Okay, we'll move to questions part. So the first type of question that I will be giving is related to, so we'll have type 1 type of questions. We have learned very much theory till now, not so many questions. So now only questions will start. Okay, questions will start. Then again, we have a bit of theory left that we will do later on. So the first type of question that I will be giving is that type of question that has relation between A and R. Okay, so relation between A and R. So please let me give you first question. Okay, fine. Raise your hand if you are a JE aspirant. Raise your hand if you are a JE aspirant. No one. Raise your hand if you want to give NEET. Okay, a lot of people for NEET. Okay, fine. So let me give you some questions related to that is from NEET. Okay. Can you write this question? First question. Okay. This appeared in NEET 2020 है ना. आसान क्वेश्चन है. नीट देख के घबरा मत जाइएगा आप लोग बावरों की तरह. ठीक है, इजी क्वेश्चन है. सिंपल रिलेशनशिप बिटवीन ए एंड आर. एटॉमिक रेडियस पूछा है. आतिफ ने एक जवाब दिया. Waiting for others. Yes, Sayyid Muhammad has given another answer. Abdul Rahman has given another answer. Hishma, Muhammad Saif. Zaifa has also given answer. Minashi has also given answer. I think everyone has given, right? कोई है जिसने नहीं दिया हो? खलील ने दे दिया आंसर. मीनाशी, हुजैफा. Yes. नहीं. Khalil, you have not given the answer, no? नहीं, खलील ने अभी दिया है. Okay, fine. खलील ने भी दे दिया. Fine, fine. सैफ ने दिया है. सैफ ने भी दे दिया. Okay, fine. So I think everyone has given. Atif has also given. Okay. So this was very easy, right? This was very easy. An element has body-centered cubic structure with cell edge of 288 picometer. 288 picometer. And you have to find the atomic radius. So we know what is the relationship. The relationship is a root 3 is equal to 4r. So r will be equal to how much? R will be equal to root 3 by 4 a, and root 3 by 4, what is a here? It is 288 picometer. So option D, है ना? Option D. I think we don't even need to raise the pen if you remember this formula. A root 3 is equal to 4r. Okay. So in order to just to show you guys how to do it, I have written, but these type of question, they don't even need you to raise your hand. Then one question I gave that in assignment, a similar type of question, that was I think in NEET 2019. Okay. So you have solved two questions that is related to relation between A and R. Relation between A and R. Okay. Now there is another question which is regarding formula. Okay. Formula of compound. Formula of compound. So for formula of compound, you have to remember a few things. So the important thing that you have to remember is the contributions. Okay. You have to remember the contribution. Okay. So contribution of corner is how much? 1 by 8. Contribution A of face center is how much? Tell me. Okay. Face center's contribution is? This is for cube. Okay. Face center is 1 by 2. Hai? Then you have H center. H center is equal to 1 by 4. Then you have body center. Body center is 1. All of you know this? Yes or no? सबको आता है ना ये?
Yes, sir.
अरे हाँ या ना बोलिए, है ना? सबको आता है. Okay, fine. So let me start with first type of questions. So in formula also, now there are two type of questions. In the type 1 question, what you will be given the exact positions of the atoms, as in this example. Okay. So in this example, you can see that a cubic solid is made up of two elements, P and Q. It's made up of two elements, P and Q. Don't write anything, please listen. Atoms of Q are at the corner, so they have given you. Okay, first thing is that it is a cubic solid. So there is a cube in the corners. We have Q atoms, and P atoms are P is at the body center. P kahan pe? Body center mein. Then you have to calculate what is the formula of the compound. So how to do these type of questions? Very easy. It's very easy. You just have to do what I say. First of all, you will write the atoms of Q. पहले बताया तो you will write Q atoms are present in corner. So you have written like this. Now you tell me how many atoms of Q will be there in a cube? How many corners are there? How many corners are there? In a cube, how many corners are there?
8.
8 corners. What is the contribution of each?
1 by 8.
What is the 1 by 8, which is equal to 1. Then you will circle this number. Then you will write P, and then you will write body center. So how many body center atom can be there? There can be only one body center atom, and its contribution is also equal to 1. Then you will write 1. And then you will write this is also equal to 1. Then you will circle it, and you will write the formula will be equal to P1 Q1 or just PQ. Any problem?
No, sir.
Any problem? No, na? So first of all, in this type of question where you have been given explicitly the positions of atoms, you will write the position of atoms, whatever given. Then you will write the number of those particular atoms, and after that you will write the contribution. Then whatever number will be there, you will circle it. Then you will write for the next one, same things. Then you will write whatever you have circled, it should be in the subscript P1 Q1. And then you have to simplify it to the whole number ratio. You have to simplify it to the whole number ratio. Now in this question, they have asked one more thing. What is the coordination number of P and Q? Coordination number of P and Q. So it is very simple. Now P and Q are forming BCC type of structure, right? So P and Q has coordination number that is equal to 8, right? For body center, the coordination number is equal to 8. Is this clear? Yes or no? Please tell me. Is this clear, guys?
Yes, sir.
Yes, sir.
Please write this down. Anna, please copy this. We will look more questions. Okay, we'll look at more questions now. इसको कीजिए पहले. Let me know if you're done. Are you done, guys? Yes, are you done?
1 minute, sir.
1 minute. Okay, okay. हाँ बोल दीजिए, कोई दिक्कत लिखिए, आराम से लिखिए. Syed Muhammad is done. Atif is done. Those who are done, they can write this question. If you're done with the second question, please send the answer in chat. Okay, 1 more minute for the second question. Okay, I think I've got one answer. Okay, fine, Atif. Let us see. Let us see. Those who are done with the second question, please send the answer in chat, A, B, C, or D. Okay, only Hishma has given and Atif has given me. Okay, please turn your mic on and tell me B is occupying. Okay, first of all, A. Where is A? Where is A present? What is the position
Corner.
of A? Corner. How many corners are there? In a cube, how many corners are there?
8.
What is the contribution of each?
1 by 8.
1 by 8. This will be equal to
1.
1. Where are B? Where is B?
Face center.
Face center. But if one atom of B is missing from one of the face center, that means face center minus 1. Okay. So how many face center atoms are there? Face center, how many face center is there?
6.
6 minus 1 into, what is the contribution? Y minus 1, all of you understand this, right? Y minus 1,
Yes,
because it is saying one atom is missing. Okay. What is the contribution of each face center atom?
1 by 2.
Half.
1 by 2, half. This will be equal to 5 by 2. Correct? Yes or no?
Yes, sir.
Now we have A1, B 5 by 2. So we need to convert this into simplest whole number ratio. We'll multiply 2 in A and 2 in B5 also. So we'll get A 2, and if I multiply 2 here, I will cancel these 2 and the multiply 2, and I will get 5. So A2 B5. So C is the right answer. Got it, guys? Yes or no? Please tell me.
Yes, sir.
Okay. Now let us look at one more that I want to give you guys. It's a bit different. Chali mil gaya. Okay. This is another question. Now you guys tell me. A crystalline solid has a cubic structure. Don't write anything. In which tungsten W atoms, tungsten W, atomic symbol is W, are located at the cube corners of the unit cell. Oxygen atoms are at the cube edge. Sodium atom is at the center. Sodium atom is at the center. What is the molecular formula of the compound? So again, we will start with simple W. It is present where it is present. What is the position of W?
Corner.
Corner. How many corner atoms? 8. Contribution is 1 by 8, which will be equal to 1. Any doubt till here?
No, sir.
Okay. Now oxygen atom. Where are the oxygen atom?
Edge.
अरे बस सैफ ही बोल रहे हैं, बाकी लोग क्यों चुप हैं भाई? हुजैफा, हिश्मा, खलील, you also can speak ना. Where are the O atoms? Please tell me. Please turn the mic on and tell me where are the O atoms. कोई क्वेश्चन भी नहीं पढ़ रहा है क्या यहाँ पे? Where are the oxygen atoms? हाँ, आवाज नहीं आई आपके खलील. Yes, मीनाशी, हिश्मा, क्या हुआ? आप तो बोलिए.
The edges.
Edges, right? How many edges are there in a cube? How many edges are there in a cube? कोई नहीं बोल रहा फिर. Edges
12.
नहीं पता आपको? 12. What is the contribution? Contribution of each edges?
1
Khalil,
by
आपके
4.
1 by 4. So this will be equal to 3, right? Then we have sodium atom at the center. Center means body center, okay? Center means body center. So we'll have 1. Contribution is also 1. This will be equal to 1. So we have 1, 3, and 1. Right? W is 1. Oxygen is 3. And Na is 1. Now we know that for write the metals are written first. So you'll write it like this: sodium. Then you'll write tungsten and O3. Okay. So this is the formula of the substance or formula of the compound. Now next type of questions that comes are a bit different, and let me give you guys those type of questions first. Next question is, please look here. Now, in this type of question, you are not given, this is type 2, okay? type 2 on formula questions. Okay, type 2 formula of compound questions. In this type of questions, you will not be given the exact position of the atoms. You will not be given the exact position of the atoms, but what will you be given? You will be given the unit cells or the pack, and you will be given that other atoms, they are occupying voids, tetrahedral voids. Hai na? Okay. So in this type of questions, what are the information that you need? Information that you need is the Z of different packings. Okay, Z of FCC, BCC, है ना? Z of HCP, sub 3D में, everything is 3D, simple cubic. Okay, all of the Z for these type of packings, and also the number of tetrahedral voids or whatever the void is present in these type of unit cells. Okay, so these are the two information that you need to solve this type of questions. Now in this question, a compound is formed by two elements, M and N. N forms CCP. सबसे पहले लिखिए आप N. It forms CCP. What is the unit cell of CCP? It is FCC, face-centered cubic. I hope you have written this. And then what you will write? You will write the Z of FCC. What is the Z of FCC, guys? Tell me. ये आपको आना चाहिए. Z of FCC. What is the Z of FCC? Minashi, once again.
4.
4. Correct. Then they are saying M occupies, and 4 is the number you have got. M occupies 1/3 of tetrahedral void. So M is occupying 1/3 of tetrahedral voids. Okay. So that means I will write 1/3 into how many tetrahedral voids would be there in face-centered cubic in FCC? 2n ना 8 हो जाएगा. Yes or no?
Yeah.
This will be 8/3. ठीक है. तो आपका M क्या है? M is 8/3 and N is 4. So what we will do, we will simplify this. So we'll get M, which is 8, and you will get N. 3 4s are 12, right? If you multiply 3 both sides, the 3 will be getting cancelled from the M side, and 3 will be multiplied on the N side. That will give me 8 and 12. And then you will divide this thing with 4 once again. You will get M2, N3, M2, N3. So it is very simple. You have to first of all write the Z for whatever is forming the packing. If N is forming the packing, then you will write the Z for that. Identify the unit cell first. So for CCP, the unit cell is FCC. And then you will write the how many tetrahedral voids are there and how many of the tetrahedral voids or octahedral voids it is occupied. Please write this down. Let me know if you're done by raising your hand. And I think you must not have written the previous question. So usko bhi likh lijiye. अब सिर्फ सवाल, okay? Only question. In the next class also, we'll be looking at a different type of question that is dealing with the density. We will look at density in the next class. But again, only questions, nothing, no theory. अब कोई theory नहीं है. There is theory, but it is very minimal. It is mostly about what are the characteristics of solids in atoms and solids are closely packed. And so those type of theory is there only. Then you have a bit of theory in types of classification of solids. There are molecular solids, ionic solids, okay, covalent solids. So these type of solids are there. So those theory is present, but otherwise the main theory is done. Majority of the chapter is done. Conceptual part is done.
Sir, can you scroll it up?
Riddle up, you have not written the question.
Yes.
जल्दी लिखिए भाई, टाइम खत्म हो जाएगा. I have to do one more question. अच्छा, take screenshot guys, take screenshot. Let us discuss this last one. I hope you all can do this type of questions. Let us discuss this last one, then you can start writing. Okay, I'm giving you guys 5 seconds. Just take a screenshot. 5, 4, 3, 2, and 1. Okay, so coming back to our question. So you can see our question here, right? Ferric oxide, it crystallizes into, tell me, it crystallizes in, what is given here?
Hexagonal close.
Hexagonal close packing. So this is hexagonal close packing in 2D or 3D? 2D or 3D? Tell me. Tell me guys, it is 2D or 3D? जल्दी बताइए, 2D or 3D? If nothing is given, it is always 3D. If they have not specified anything, it is going to be 3D, because our real world, it is 3D. 2D is just imaginary. 2D solids are imaginary. If they want to ask about 2D, they will mention especially explicitly that it is 2D. They have not mentioned anything, that's why it is 3D. So ferric oxide crystallizes in a hexagonal close packed array of oxide ion with 2 out of every 3 octahedral holes occupied by ferric ions. Derive the formula for ferric oxide. So in this very important questions, we have this line: in a hexagonal close packed array of oxide ions, है ना? That means our oxygen is at Hcp. Is that right? Yes or no? Right? Oxygen ions, oxide ions are at, it is forming Hcp. Yes or no? Can all of you see that in the question? Hexagonal close packed array of oxide ions. Can I get a yes or no, sir, please?
Yes, sir.
Yes, sir.
What is the Z of Hcp? What is the Z of Hcp? हाँ मीनाक्षी बताइए. 6. So we have got this 6, and they are saying 2 out of every 3 octahedral holes is occupied by ferric ions. So we have iron, and it is occupying 2/3 of octahedral voids, na? Octahedral voids. That means 2/3 into how many octahedral voids are there? There are 6 octahedral voids in Hcp, because it is equal to octahedral void, it is equal to n, है ना? So this will be multiplied, and this will be 2. So you'll get here 4. So you get the formula as Fe4O6, है ना? Or Fe2O3. See, simple question. Okay, very simple questions. Very simple questions. चलिए, copy this one. Let me know when you are done, or take a screenshot और घर जाइए, है ना? I think some of you will be having iftar in 2-3 minutes. Okay, so goodbye, bye, goodbye. Take care. Thank you very much. Take a screenshot. Take a screenshot. Okay. Can you explain the first part? Which part? Can you please turn the mic on, Abdul Rahman?
Yes, sir.
हाँ बताइए, क्या दिक्कत आ रही है इसमें आपको?
HCP or oxygen.
HCP and oxygen. What you don't understand? Are you not understanding that oxygen is forming HCP, or you don't understand that the number of atoms will be 6? Which part?
I understand that oxygen has HCP.
Acha, oxygen is HCP. Fine. So it is there in the question only, na? Ferric oxide crystallizes in a hexagonal close packed array of. So this HCP, na? HCP is of what? Of HCP is of oxide ions. It is given. ये लिखा है ना, HCP of oxide ions, right? Yes or no?
Yes.
Got it now?
Yes, sir.
है ना? But if it was written that CCP of oxide ions, that means we would have taken the face centered cubic, and the Z would have been equal to 4. If it was given body centered cubic, then we would have taken it as 2. If it was given simple cubic, we would have taken as 1. Okay. So it crystallizes in a hexagonal close packed array of, this array is of what? Oxide ions. Okay. Write this down. Let me know when you are done. Take a screenshot, okay? Take a screenshot.